start off my video, I'm going to be explaining the mathematical equation for ideal gases. The mathematical equation is PV equals nRT, which pressure times volume equals the number of moles multiplied by the constant multiplied by temperature. Okay. Then to solve for pressure, you can also divide by V. So pressure equals nRT over V. Now I'm going to be explaining the motion of particles. The molecules are always moving faster and knocking against one another with higher kinetic energy during an ideal gas state. So to explain pressure and how we measure pressure, we can measure it in atmospheric pressure or millimeters of mercury. So exactly 1 atmospheric pressure equals 760 millimeters of mercury. To measure temperature, obviously we can measure it in kelvins or Celsius, but when we use the ideal gas equation, we prefer to measure in kelvins. So you would take your degrees in Celsius and add 200. Now I'm going to be explaining Boyle's law. This equation relates pressure and volume, which are inversely related. So the mathematical equation for that is P1 multiplied by V1 equals P2 multiplied by V2. Next I'm going to be explaining Lusak's law. This is directly related. This is pressure and temperature. So P1 over T1 equals P2 over T2. Now I will be explaining Charles' law, which is directly related. So we take the ideal gas equation and then we will change it to pressure equals, in parentheses, number of moles multiplied by R over V, close parentheses, multiplied by our temperature. Okay, so now I'm going to be explaining what happens with a soda bottle without shaking it. When you don't shake a bottle of soda, gas is able to increase its volume in order to decrease the pressure. The whole goal is for carbon dioxide to escape. When shaking a bottle of soda, all the gas bubbles want to expand because of high pressure. Pressure goes down and volume goes up. To go into more depth with Lusak's law, the pressure of a gas is held at a constant volume, so then pressure will be directly proportional to temperature. As the pressure goes up, the kinetic interaction increases, which means the molecules have increased their energy, which then in turn causes them to increase their temperature. A good example of this would be a pressure cooker. So as P increases, the volume is kept at a constant rate, and then the temperature also increases. Now I'm going to be explaining the relationship between volume and temperature. A prime example of this would be a hot air balloon. Hot air rises, which is why our hot air balloons also rise. Gases expand when heated, which is why the same substance will occupy a larger volume when heated. Substances with lower density, in this case hot air, rises, while cool air, which is denser, is at the bottom. This is an example of Charles' law.